So now in this video, we're going to use the LM358. It's a single supply op amp, so you can use it with a single supply where you have a positive and negative, or you can use it with a dual supply where ground is a middle way point between positive and negative. But we're just going to use a single supply because I have a single supply. But in any case, it's the LM358. We have the output feeding back to the inverting input. And what that does is, when you have that, especially the direct feedback, the voltage you apply at the non-inverting input will be the voltage at the output. Thanks to that feedback, it tries to keep those voltages the same, the best it can by changing the output. In this case, we're going to light an LED. So, as I said before, we're going to have the voltage there, but it's not going to be, at times, the exact voltage of the trim pot that I'm going to set it to. So if I turn it all the way that way, it's going to be up to the supply voltage. We're going to use 8 volts. If I turn it all the way down there, it's going to be 0 volts. But if this is at 8 volts, as is that, and I quickly put it to 0, it's going to take time for the capacitor to discharge to 0 volts, and thus it's going to take time to get 0 volts at the input there. Current doesn't go in or out, it just looks at the voltage, and thus it's going to take time for the non-inverted, the output I should say, and the inverting input to get down to 0 volts. So the LED is not going to change instantly when I change the voltage. So now I'm not going to do a complete step-by-step build. I've done a number of videos with circuits very similar to this one. We're going to just look quickly at the case that I got the LM358 out of. We have the output on top right there, that's where the LED is, and just like my schematic, the inverting input is above the non-inverting input. So we got those two right there, and as you can see, we have a trim pot right there, 10 kilo ohm trim pot just because that's what I have, and a 1 kilo ohm resistor, jumping that gap there to the non-inverting input. The inverting input, we'll add the capacitor in a little bit. The inverting input, as you can see, we have the output and the inverting input tied together. So that's the top 2 pins. I have this little jumper that I bent. It's plugged into both rows. I also have little jumpers with no insulation. They're harder to see, but that's connecting those 2 rows. And at the output, I found it just easier to put the LED before the resistor, but we have the anode towards the output, the cathode up here. The cathode goes to a 1 kilo ohm resistor, so that we could go up to potentially 12 volts, and that is going to the negative rail right there. And I almost forgot, I got the oscilloscope ready. We need to power it. So you can see pin 8's to the positive, pin 4 is to the negative, which is ground in this case, since it's a single supply. Not all op amps have the same pin layout. This one has 2 op amps, some of them only got 1, and then sometimes the ground and the VCC are in different spots altogether. So make sure you look at the pin layout of every op amp if you are not sure exactly what it is. So here we got the alligator clip from the oscilloscope, the red, and then the black one here to this blue jumper. We're going to look at a voltage in relationship to ground right there. So I haven't added the capacitor yet. This is going to be a delayed voltage follower, but right now it's just a voltage follower. So we're going to go to the input right there, and the voltage is low enough where the green LED is not lit. And I can go lower, and, or no, that's as low as I can go. That's right, I changed. I lifted that up there when I was testing it out. I forgot about that. I'm going to lower this. So that arrow is 0 volts, and we'll set it right there. Now, I'm going to, each square is 1 volt by the way, I'm going to raise it up. And you notice the brightness of the LED changes right when I turn the trim pot right there. And we can lift this up and put it to the output. I think I'm sharing a hole with the resistor, but that's okay. And there you can see the output changes right when I change the trim pot. And so now I'm going to remove this altogether, get out of the way. So this is a 1000 microfarad capacitor. And so if we wanted it to take longer, we could use a larger value capacitor, but this is a pretty large value capacitor for basic electronics. we could also just use a larger resistor right there, which would be the better option. And if we want to speed it up, we can make either one of them smaller. So there we added it, and already the capacitor looks like it was discharged. It took time to charge and the output to go high. So we are not measuring voltage at all at the moment. So let's go back to the where the capacitor is. We'll look at that voltage. So right now it looks like a little less than 4 volts. We'll go down, but I'm going quickly all the way to nothing. There you can see it took time to go down, and it's taken time to get completely to 0. Now we'll boost it all the way up, and so we're dealing with 8 volts. There you can see it did rise quickly, but not suddenly, and it did get to 8 volts. So now this is the LM358, as I mentioned before. Reason why it's a single supply is because it gets to 0 volts really well. And if you're powering something at 0 volts, I think it struggles quite a bit more to get to 0, but it's not doing anything at 0 volts now, and so it really easily gets to 0 volts. But that's why it's a single supply. It can get to 0 volts. We're going to go to the output now, and again, I think I'm sharing a spot with the LED. So we already saw the LED takes time to start lighting up when we turn this dial suddenly. Turn it up. So I'm going to go up all the way as quick as I can right there, and there you can see it took definitely a lot more time to get up to that voltage. So it's a single supply because it can get to 0 volts really easily, but like a lot of integrated circuits, it cannot get to the full supply voltage, the positive right there. So it falls about 1.5 volts short. If you use more voltage, instead of 8, if we use 12, then it would get up to about 10.5 volts right there. But in this case, it's up to about 6.5. So that's something you gotta look at with any integrated circuit that you're using, is the voltages that the output can get to. That may influence a circuit that you're gonna make. You may have to find a different integrated circuit. But in any case, that's it. Adding this capacitor, we can add a delay as long as we have resistance as well. It'll take the capacitor longer time for its voltage to change, even though our signal is technically this trim pot here. The capacitor is a middleman, and it's delaying that signal from reaching the input, the non-inverting input, and thus it's taken a longer time for the voltage of the output to catch up with the input right there. So not terribly complicated, but it's still an interesting circuit, and I hope you enjoyed. Make sure you check out one of the other videos that I'm posting. Click like, subscribe, the bell, and all that. Donate to Patreon if you can. I got all the links down in the description. That would help out the most. But just watching this video helps out a lot, so watch more if you can. Thanks for watching. I'll see you in the next one.